Hello everybody, this is Lino Tadros again, and in this second video of the part number 4 is when we're going to start creating multiple extracting summaries from the content of the 2.5 minute call. So I'm going to try to use 3 different ways of doing the extraction. I'm going to use something called extractive summary, and then we will use something called abstractive summary, and then we're going to use a query based. Just to give you an example, what exactly is the difference between these things. So in Azure AI Speech, for the SDK, an extractive summary, it pulls key sentences directly from the original text to create the summary. So it doesn't actually create new sentences, it just extracts it from existing lines inside of the original text itself. While if we use the abstractive summary, that actually generates new sentences that capture the main points of the text. So it's almost from a mile high, it looks at everything and it comes up with its own summary with the abstractive summary. It does it always by paraphrasing, okay? And the last one, the query-based extraction, it allows you to focus the summary on specific information by providing a query that guides the extraction process itself. They're all 3 of them are pretty useful. You just have to decide which one is best for what you're trying to do. So let's go ahead and get started. If I go back to my Visual Studio Code, you'll notice page number 4 in here for the dashboard application call center Python. If I open it up, let's go down to all the extraction. We've done already the transcription and everything, and I'm ready now to take a look at the extraction of the data. Okay, there is the first one. There's a Python function called generate extractive summary. It is not implemented, as you can see in here. We're going to implement this in a minute. And then we will have the abstractive summary, and then we will have one with the query-based summary as well. None of them are implemented. We're just going to bring in some code for each and every single one of them to see what's happening. The things that you will, of course, need, if you remember in Lab 1, all the way in the beginning of this series, we've actually used the speech endpoints and the speech API key, also the language endpoint and the language key. So all that stuff is available in our Streamlit secrets that I included. I'm running here locally on my machine. That means when you deploy this to Azure, you have to make sure that this information is available in your app settings as well. The most important thing, of course, we're going to take the list of strings that it's a parameter being formatted for the call content. It's coming in as a list of strings, and I need to actually join all of those to join them together with spaces to pass in as a single document for that. So obviously I'm not going to use this line. So let me comment it out. You can delete it as well. That's fine. And instead of that, I would like to bring in some code to explain what exactly is extractive summary. So let me go ahead here to the beginning of the line, because Python is very picky about the spaces and the tabs. And let's see if we've done this right. Yeah, it's good. So the first thing is I'm going to use from the SDK, from this API speech for Azure, the text analytics client. Okay, this is connecting to your language service endpoint itself. And then I'm going to start with the begin analyze action, passing in the entire document that I joined together. And we're going to use one of the action, which is extractive summary action. In here, passing maximum sentence count is 2. That means I'm asking you to extract at most the 2 most important sentences from the transcript, okay? So you can change and play around with this number to see if you get different understanding as well. So these things will happen in every single one of the extraction, but this one I'm using extractive. The next one probably I'm going to change the action to be abstractive, and then the last one will be the query-based as well. And finally, when they extract the summary sentences and merge them into a single summary string, I'm going to go for a for each, and I'll be able to bring in the result and get you the value of the content coming in from there as well. Alrighty, so, and I'm going to call it, by the way, in JSON call summary. So that's the name of the item in the JSON itself for the key, the call summary, and I'll bring in the entire extractive summary as well. And we will probably do something very, very similar for the abstractive, except the action will be different as well. As a matter of fact, let's do it for the abstractive as well, so we can be done with this one. You can delete it if you want this line. This is just a placeholder, and I'm going to paste in almost similar code. So you'll notice everything is the same, the text analytics client. I'm going to start the begin the analyze action, but the only difference is the action now is not using extractive, it's going to use abstractive summary. I'm also going to use 2 sentences max for getting the summary itself from abstractive. The rest is pretty much the same, and I'm actually using the abstractive summary to be passing to a JSON that has a key called call summary that I can actually get from the dashboard application to be able to display that in the user interface as well. Make sense? All right, we have one more to go through. Let me go down. This is the query based. Again, I'm going to be joining all the list of strings to make it a document. And instead of doing this placeholder, let me go ahead as well, like I did before, comment this out. And this one is pretty simple. You have to understand really what I'm doing with this. I have to involve a model like a GPT-4o to do actually the summarization based on the query. So as a matter of fact, if I bring in the code for this one, let me show you. It's actually smaller, but hopefully you'll understand what's going on in here. I'm going to create a system prompt that says write a 5-word summary and label it as a call title, and then write a 2-sentence summary and label it as a call summary, and output the result in a JSON format. So that's my system prompt, and I'm going to make the call like we saw all the way to the beginning of this file, make Azure OpenAI chat request, passing the system, and then the join call content. So it is not going to be based really on the Azure AI speech. I'm not doing extractive or abstractive. I'm counting on a multimodal like GPT-4o that has audio and it has vision, it has text as well, and I'm telling it, hey, this is my system prompt, this is the document that contains all the list of strings inside of it, and I would like you to make that decision to let me know what would be a good call title made out of 5 words, and also the call summary give me a maximum of 2 sentences to describe the whole thing. So I'm going to Control S to save all of this, and now I have all 3 of them implemented correctly at this point. All right, we have one more thing to take care of. Let me see what that is, and that's the big one. All right, that one is a function that will create sentiment analysis and opinion mining requests, okay? And this is very important. This is a real life scenario in here. I don't want to give you the sentiment on the entire call, okay? This is a 2.5-minute call. A lot of people actually say, take a look at the entire document and let me know if it was positive, negative, or neutral, whatever. But in reality, management is looking for something a lot more than that. I don't want a sentiment on the entire call. I want a sentiment on every single statement, or during the discussion, I might have like 30, 40, 50 different sentences that's going back and forth between the customer and the agent. And I want to make sure that I follow the sentiments on all of them. A lot of management will take a look at this as it started negative, the customers was unhappy, and then by the end of the call, it was positive. That means our agent did a pretty good job to take them little by little during a 2.5-minute conversation to bring them from a not a very good place where the customer was, and at the end the customer was grateful and thanked the agent and was happy with the answer. So it's not always a sentiment for everything. Sometimes you want to go through the entire phone call and find out. Sometimes it goes from negative to positive to back to negative to neutral, and all the way at the end, if you are lucky, you will get them to be happy and it will be positive. And this is something important for managing. So don't think that you have to get one sentiment for the entire call. Sometimes it's more important than that. All right, I'm going to go ahead and comment out my placeholder in here, and I'm going to bring in some code. And this code in here, actually, there's a lot of comments in it so that you can actually see what we exactly are expecting in here. Let me see. Where does it start? There you go. So what we've done in here, same like before, we do the text analytics client, passing in the language endpoint and the credentials for the speech API and all that. But the important part is I'm not going to use extractive at this point. I'm going to use analyze sentiments, passing in the entire content, and I'm going to turn it on show opinion mining equal to true to go through every single statement going back and forth between the client and our customer service agent. And then I will retrieve all the document results that are not in error. And there is a comment in here to show you what I'm expecting from the JSON. So this is just a sample to show you what will be coming back from the JSON. My job is to write the code that will create that format. We'll create an object in JSON. We'll have the sentiments, the sentiment scores, positive, neutral, negative, and all of these. This is the format I would like to create. So you will notice I'm starting with a sentiments object that is empty, and then I'm going to go through every single document in the doc result, and I'm going to be creating the JSON document. Notice it was empty. Now I'm going to actually create a sentiment, passing in the document sentiments and the score, positive, neutral, and negative. So I'm really creating that commented out green area to be able to create that one by one from the system. I know it's a lot of code in here, but if you go through it, it's just my way of creating a JSON object that I can actually trust based on all the elements inside of it as well. And in the end, I will return my sentiment object that contains everything regarding every single statement, whether it was positive, neutral, or negative in the discussion. All right, let's go ahead and save this And I would like to go ahead and compile this one more time. I think it's Python M streamlit run, and hopefully the new code is in there. I saved everything, and then it will open up localhost 8581. And let's see if my extractive and sentiments, all four of them, will work for me. So I'm going to go back to the call center again. Remember, this is running locally. You are more than welcome to run or check this into GitHub, and that will automatically run the workflows, and you'll be able to run it inside of Azure as well. Okay, so I'm going to go ahead and do browse files. There is our wave files for 2.5 minutes, and it will do the same thing again. We'll wait until the transcript is done. But my interest after it's done is to go down a little bit and being able to see the extractive, abstractive, query based, and all of this. This will be very important, including the sentiment as well, and see if our code is doing a pretty good job being able to take a look at a 2.5 minute audio file, or it could even be live streaming if you like, and it can do it on the fly as well. So we can you can experiment with that. Let me go ahead and stop the video, because this will take between 60 to 90 seconds to do this, and I'll come back when it's done. All right, it took about 70 seconds, not too bad, a little bit over a minute, but there it is. And I'm not going to run the compliance again. We tried this before and it works just fine. I am interested in the other things. I would like to tell it, go ahead and show me extractive summary. That will call the Python function with the code that I just added. Let's see that. Generate extractive summary. And now you will notice that it will come back with sentence already exists. It will not create brand new sentences or anything like that. So we'll give it a few seconds. And when it comes back, we will see what happened. Okay, let me see it refreshed 1 second. Okay, I had to refresh the page, but it looks like the call summary, that's the name I gave it actually to use as the key in the JSON. And it says, I'm hoping to change the date from the hotel. So notice it did not summarize in a way that it will give it its own words. It actually had to use data built inside. And I told it only to give me 2 sentences. I could have actually for 5 or 6 and be more, but this is really the summarization as far as extractive summarization is complete. Let's go ahead and do it with abstractive summary. I'll click on abstractive. We'll click on the generative abstractive summary. We'll give it a few seconds, and when it come back, now it will be pretty much taking a look at it from a mile high. This is not using wording or sentences from the transcript itself. So the abstractive will say, Parker McLean contacted Contoso Suite to change some details of his upcoming stay. He initially planned blah, blah, blah. And you can see this is not content that is available in the transcript itself. Make sense? A lot of people like this more. But again, it all depends on the citation and the proof that you'd like to show part of your summarization as well. Now let's go ahead and do it with the Azure OpenAI summary. It means instead of using the Azure AI speech to do the summarization, I want to send everything to GPT-4o and be able to see what the 5 words of the title and the 2 sentences that I actually told it to do. So let's go ahead and click on that. We'll say generate the query-based summary. Now it's being sent everything. It's very fast going GPT-4o. The call title, reservation modification request fulfilled. Awesome. Even though I told it to come up with 5 words, but it thought it can do it in 4. Already the call summary, the customer, Parker McLean, called Contoso Suite to change his existing reservation, blah, blah, blah. And all this information will be in here in, again, 2 sentences max to be able to describe the entire call. All right, the last one is the sentiments and opinion. Remember, we did this, and I told it to bring me back a specific format in the JSON so I can actually use it in my application if I want to. So if I say sentiments and we'll say analyze the sentiments, this is the part I really like. I do not want a sentiments on everything. So automatically the first part, it will tell you about everything. It's mixed. There was 82% positive, 12% neutral, and 7% negative in the call. This is awesome summarization of what happened. Then I'm going to go into every single sentence from 0 to 1 to 2. If there is 20, there will be 20 of them in here. And we'll say good afternoon and thank you for calling Contoso Suite. That's positive. And it will give you again the scores on that sentence. And you can keep going neutral, neutral. I want to see the one that is negative to see why did it call it negative. All of these are neutral. Let's see if we can find the one. I've seen it here before somewhere. Hopefully they were not happy about something. Oh, there it is. The word unfortunately triggered it, but it does not appear the Downtown Plaza Hotel is available for your dates. However, I do have availability for both a room and meeting rooms at the Grand Contoso downtown Seattle. And that positive, there was nothing positive. I disagree. The guy actually found a place for them to stay, so there should be a little bit of a positive in there. The neutral is 24%, but negative because we said it's unfortunate and you have to share that information with the customer. It put it at 76%. All right, so you can see that this is actually working. The majority of them are neutral. There is a lot of positive and very little negative that is appearing in here. So it is not enough for me to have the mix all the way in the beginning. For management, that's usually not enough to have only the first piece, to tell you, all right, it's 82, 12, and 7, the percentages, and it's a mixed. I could tell this ended up being a very positive phone call, and at what point it became negative, what point did it come back from negativity to be positive, and management can make decision based on that. Hopefully that makes sense for this video. I'm going to stop on this one, and then the third one we will go a little bit further for implementing a vector search on all of that and save it actually in our Cosmos DB as well. Thank you for watching, and I look forward to presenting the last piece of the lab number 4 in the next video. Thank you.